Discovery's 4 computers now have primary control of critical vehicle functions.
All right, everyone, welcome to today's ASRG webinar. But before we get started, I'd like to tell you a little bit about ASRG and get some of the legal stuff out of the way. ASRG is a nonprofit organization founded to support the development of the automotive security industry. We have developed a platform and a community to share knowledge, communicate through networks, and to build value with collaboration. This is a community for you, built by you, with the goal to protect our friends and family when using automotive products. If you want to learn more about ASRG or get more involved, please visit our website at www.asrg.io or send us an email at hello@asrg.io. Before we jump into the presentation today, let's get some of the legal stuff taken care of. The views and opinions expressed in this webinar are the views of those that have made them. They do not represent views or opinions of ASRG and are to be considered as informational. The use of this information is to be used by the individual and or organization at their own risk.
So this is the Autonomous Vehicle Cybersecurity Development Lifecycle presentation. And I am Charles Wilson. I'm a principal engineer for cybersecurity development lifecycle practice at Motional. Speaker bio will be in the PDF of the slide deck. Just a couple highlights. My background is in computer science and electrical engineering, and I hold a CSS LP. I've worked in multiple different areas and in the cybersecurity realm. Most recently, I've worked with both medical devices and with Motional in autonomous vehicle system development. I sit on multiple ISO committees, including the US tag for ISO 21434, and am the vice chair of the SAE Cybersecurity Maturity Model Task Force, which is looking at how to propose maturity models for ISO 21434. And I am the primary author and editor for the Autonomous Vehicle Cybersecurity Development Lifecycle, or AVCDL for short. So ISO SAE 21434 is finally here. As of the end of August 2021, it is now an international standard for road vehicle cybersecurity engineering. So there's a shiny new standard out there. How are we going to get compliance with it? What are we going to do? Well, my approach to this, and the reason that I was hired to Motional, was to look at that very problem. How do you get certification against the new standards for autonomous vehicles? And if you have dealt with an ISO standard, they are not something you can just plug in and do something with. You need to adapt them to the way that people will end up doing development. So let's step back and look at some lifecycle basics. At the root of everything are the policies of the company. And those are basically the why. It's like, what is the motivating factor for all of this? The second element are the processes. They're the what and the who and the when of things that implement the why. And finally, we have procedures. which tell you how you're going to do this specific process implementation that you have called out. Now, a life cycle is the collection of processes that are used. Life cycles have assumptions. We can look back to, well, we could look back at ISO 9000 if you want to talk about standards that dictate how you make a product. But we're only going to look back at ISO 15288, which is the systems development lifecycle. Later on, ISO 12207 came along, refining it and specializing it for software development, and unfortunately gave it the same abbreviation of SDLC. We got 26262 not too long ago for functional safety. And now we have 21434 for road vehicle cybersecurity. Now, these top four are all standards. We also have regulations. In the case of the UNECE, we have Regulation 155 for Cybersecurity Management Systems, or CSMS. CSMS actually refers to 21434 for specific elements of cybersecurity engineering. So how do these standards line up? This is the 15288 systems SDLC, and we can see that there are a fairly reasonable list of different phases and processes that we undertake. Everything from the technical processes through to the disposal and also agreement processes. Well, when 12207 came along, since it was a specialization, it basically looks the same with some tweaks for the fact that this is software. And you'll notice that things don't quite line up as you go along. 26262 brought along the idea of a concept phase. You'll note that those don't exist in 15288 or 12207. Gets a little bit more specific. It's not just technical processes, it's management and support processes, or supporting processes. And down at the bottom, we have more supporting processes. In the middle, it starts to get interesting because we're grouping things together and we're adding additional extra ones. Then we get 21434. It looks kind of like 26262, except when we get into the actual operations, we get more specific and talk about operations, maintenance, decommissioning, things that happen continuously. And now we're being much more specific. We're saying distributed cybersecurity activities at the very end. Well, if you look at the way that you do projects to create products, and you have to deal with issues of certification, you're going to want to be able to synchronize your different groups. You're going to want to have them able to speak a common language. You don't want to have the systems group go through their requirements definition and their requirements analysis and their implementation and have someone in that group say, hey, we're working in implementation. And all of the folks in cybersecurity are talking about, well, working in development. Okay, that's nice. Development tends to be considered a group rather than an activity to the other three. And so there's no common language. So how do we make it such that all of these disparate groups can actually talk to each other, share information, and have synchronization points? Another example is that we have this concept of software installation. Okay, nobody else talks about software installation. How do we bring that together? The AVPDL is a simple but powerful concept, which says that there's going to be a set of generic phases and processes, and that when we talk to other groups, we're going to use that language to say that we are in one of these phases or we are executing one of these processes. We still have the problem that things don't line up and we're kind of cutting things, but you'll notice the things that we are introducing additional separation or grouping are fairly broad categories that will lend themselves to that kind of decomposition. For instance, the separation of operations and decommissioning is common among three of these three of these standards, and putting it in should not cause any great effort to be put in by 26262, for instance. Now, you notice I said that they were processes and phases. The processes are all things which at the root are managed by the organization. These are things which have to be done in accord with the overall organization because they are things which are either handled by a group which is neither systems, software, hardware, safety, or cybersecurity. For instance, project management, document management, or they are things which deal with legal agreements between companies. At the bottom, we see the supplier processes, agreement processes, and such. Those are things which exist within the framework of legal, to which there is contribution by each of the specific groups. For instance, within the context of 21434, we want to have a cybersecurity interface agreement that goes along with the functional interface agreement that exists between the vendor or supplier and the customer. The phases are life cycle phases. And those are things which, regardless of what you're doing, are implemented specifically for each of the different groups. There is going to be a set of things that you do which are solely contained for each of these different phases. Now, some things are grouped, and you could say, well, you have requirements definition and requirements analysis. Well, fundamentally, that's requirements. There's no necessity of having a finer level of granularity there. In the same way that the implementation phase, from an external view, it's irrelevant where in the implementation you are. What matters is that you are in an implementation phase. Now, the motivation for a phase is that you're going to have a gating activity that is going to be required because there is such a dependence on a previous phase that you cannot execute the next phase without having verified that you've taken care of everything that you need to. And so what we see here is that the green phases are fundamental gating spots. for project management, that we want to make sure that we've done all of the requirements handling, not just the functional requirements or the safety requirements or the cybersecurity requirements, but we want to make sure that all the requirements are taken care of. And we need to do this because we have to ensure that we have traceability. This is one of those requirements when you have a safety critical cyber physical system. Now, the foundation phase doesn't have a gate because the activities that occur within the foundation phase are ongoing throughout the life cycle. And they're either subject to refinement or you do it once and you're done. It's usable for every project. Similarly, the operation phase isn't gated because operations is ongoing. The same type of mechanisms that you use to handle issue tracking and fleet management and all of those things are going to happen regardless of which product you put within that operational phase. All of that structure and framework exists. Similarly, the decommissioning phase, you don't stop everything else to decommission individual items or even entire lines of items. Now, the question becomes, well, how do you then figure out what goes where? And at the end of the day, in order to get certification for 21434, you have to know what the things that are being asked for are. And so what we see here is a piece of a spreadsheet within the AVCDL document set that enumerates all of the work products and all of their dependent requirements for each of the different clauses in 21434. Now, we're not just going to use 21434 for the life cycle because as you'll see, the life cycle is far more expansive than the requirements of 21434. For instance, there's also a consideration of ISO 26262 because within the context of autonomous vehicles or vehicles in general, cybersecurity is done within the context of safety. There is no motivation to put in security features which are not necessitated by safety. Additionally, we look at UN Regulation 155, as mentioned earlier, the CSMS. Now, those are our standards and regulations. On the left side, what we see are best practices. We have the classic Microsoft security development lifecycle, introduced 20 years ago for application software. More recently, we see the NIST SSDF, the Secure Software Development Framework, which is a collection of many best practices within different areas of the development of software and systems. And finally, a recent addition to the NIST set of Special Publication 800 series documents is the Cybersecurity Workforce Framework within the context of the National Initiative for Cybersecurity Education, also known as the NCWF. This is an exhaustive list of jobs, their skills, the activities that go into any cybersecurity related function. So if we pull all those together, as illustrated here, we can see on the top the 21434 clauses. We can see in the middle the AVCDL, the red bubbles that surround the AVCDL phases with numbers represent the ISO 26262 sections. Below that are the SSDF practice areas. And finally, the MSSDL practices are listed. The arrows show you where they have input. And as you can see, there is a lot to deal with here. The colors, of course, are still matching. We have blue for foundational, green for developmental, and yellow for post-developmental. When we look at the life cycle as a whole and show what the, if you will, the phase requirements are, we get this type of an arrangement. In foundation, as you can see, there's lots of stuff that you could agree that just, all right, we do these things and we're just going to do them constantly, and we need to lay them out. For instance, training. Yes, we have to have training for all these things. Roles and responsibilities. Once those are identified for activities, that's it. They're done. We need toolchain support. We need to have mechanisms for requirements. We need to establish code protection. And on the second column, we can see that we need to ensure the release integrity, and we have to have a bunch of plans. What are we going to do in these cases? Incident response, decommissioning, threat prioritization, deployment. In the bottom section, we have our developmental and our post-developmental phases. The 5 gating phases that I've identified here, as you can see at the bottom, they're the gates, are requirements, design, implementation, verification, and release. Note that there's kind of this bell curve going on, that you start out with an activity and you kind of ramp up, and then you get into implementation, there's lots of stuff happening. This is what we would expect. And verification is less, and then release is less. For those of you familiar with the V model, this is the trough of the V is in implementation. And you're coming back, and in verification, you are echoing what's happened in the design and requirements. And finally, in release, what you're doing is double checking to make sure that you have everything done. And then with archiving, you're squirreling it away for later use. On operation, we have incident management, and we have secure deployment. And finally, we have decommissioning processes. For those of you who work with organizations where you are using cyclic, high frequency development, you can consider the AVCDL phases in this fashion. Now, as with all representations, you are limited by the language that you're using. You are limited by the fact that we're using a linear language where words get long, and the only way to pack them onto the screen efficiently is a rectangle. Now, from the context of safety, they wish to represent this in a V to show you that you have companion activities that are verifying that things are done properly. From the implementation of a cyclic behavior, you want to show that, yes, the wheel turns. Now, since this is a gated system, because it is a safety critical system, and we need to have that traceability, whenever you are rejected in a gate, you may go backwards fairly far, depending on the issue that's been determined. So yes, it's cyclic, but the cycle can go both ways. Great. We've got all of this background that we have put together. We know the activities that we want to do. That's wonderful. Do those activities actually get us to a point where we can say, yes, we are compliant? Well, that's what this spreadsheet lays out, this chunk of a spreadsheet. Shows you on the left all of the AVCDL phase requirements, and across the top, it shows you all of the 21434 work products. And the red ones are ones which are being handled by the organization. So these would be the organization processes. The yellow ones are free-floating requirements that needed synthetic work products so that they could be captured in a consistent fashion. And the green ones are ones that are both work products and have requirements that go along with them. Now, the AVCDL does in fact check all those boxes. And we'll get back to that in a little bit. Another thing that we want to be able to do, and we need to be able to do within the context of 21434, is to establish what the roles and requirements and dependencies are. And here you can see in a summary form for each of the phase requirements, there is an NCWF role assigned. There is a RACI assignment for each of the main groups involved with cybersecurity, whether it be cybersecurity, DevOps, development, or risk. And then there are 4 columns that show us what the input dependencies we have on them are. This is really helpful information from a planning standpoint because it shows you where you're going to need resources and when you're going to need those resources and who's responsible for the task in general, which is, again, our color coding matching that. The AVCDL itself is a not insubstantial document. There is a primary document which overviews all of the processes and talks about the motivations that we have, where the inputs come from. That document is really good at giving you a general, broad view of the life cycle. Additionally, there are over 50 secondary documents which get into much more specific kind of detail about the processes that we need to undertake. In this case, you see the threat prioritization plan. How do you deal with an issue that you find? Now, those 2 document classes are company agnostic. So that if you look at the documentation, there's nothing there that says, I'm using this or that tool. I have to transfer it this way, my expectation is that this group will review it per se in detail. It's like, you're not going to say, please turn this compiler switch on. It won't be there. That's all in the tertiary documents. The tertiary documents are the how. The how of, how do I implement this? How do I implement secure settings for my compiler? Well, when you're doing this compiler, this version, here are the settings. You should use these. They're in this sequence. Great. The secondary document would tell you, you should use secure settings. These are the general steps that you undergo to establish what those are. Finally, there's a set of supporting material that roll things up, that allow you to do sanity checking, that the AVCDL is built properly, things of that nature. Let's look at a phase requirements page. So each of these phase requirements has a name. In this case, it's threat modeling. It has a unique identifier, AVCDL design 4. So this is the 4th requirement. It shows you the owner. In this case, the security group owns this. Here's the NCWF rule. Sorry, not rule. NCWF role. Here's the RACI for it. A brief description of what's going on here. We find out that, yes, there's training that we need to have for this. We know what the phase requirement dependencies are. So previously undertaken phase requirements that should have been done in order for us to be able to execute this. And then the external group dependencies before we can execute this task. The products that we're going to get out of this, we're going to get a threat modeling report. We're going to get a ranked risk threat report, and we're going to get a threat report. Those are the AVCDL secondary documents that tell you how those things are generated. The next section is what 21434 work products are satisfied by this. And in this case, a lot of them. This points to the fact that when you do system or software development, it does not necessarily happen the same way that you would lay out an ISO standard. The next thing we have is the WP.29 CSMS, which is the R155 requirements. And finally, the CMMC best practices. This is included as an interesting reference for a relatively recent set of maturity practices introduced by the US Department of Defense. Within each of the secondary documents, we break down the actual workflow for the particular activity. In this case, what we're looking at is threat modeling. When we do threat modeling, we undertake 3 individual activities: the threat model creation, the threat model analysis, and the threat model triaging. As you can see here, we call out the actors that are participating, the inputs, and the outputs. Additionally, we have some optional feedback that's going on in the triage activity that may feed back information to the threat model. Once we have that triaging done, that goes off to the threat ranking process. Now, as you can imagine, The secondary document, which looks at these workflows, has a lot to say about each of these activities. And so those documents are roughly 10 pages each because they put time into saying, oh, well, when you're doing a threat model creation, here's what you do. These people are required. The system design looks like this. You're going to get feedback, and you may or may not generate reports or artifacts. At the macro level, we take all of this information and we can establish traceability. So this is a small portion of the traceability of the AVCDL. Now, the largish rounded rectangles represent the phases. And as you can see here, you've got foundation requirements, design, and implementation. At the bottom, you can see the color coding for who's responsible for these things, again. And you can see the dependency very explicitly in the flows. So you can look at this and say, oh, I'm going to do a design gate in the design phase. That means I have to have done the attack surface analysis report and the secure design review report and the threat modeling report and ranked and risk threat report and threat report. And then, and only then, can I say, oh, I finished looking at the design. Now, you'll notice that that one line pushes back all the way through the global security goals. And to be able to do a threat modeling report, we can push that back through 4, and that goes all the way back to the threat prioritization plan. So here we can see that we establish traceability, and we make it very obvious to everyone what that traceability is. Training is the same. We can take all of the identified training activities and we can lay them out in a structure that allows us to have the establishment of training sequences. This prevents you from having training which is duplicated or is left out because you don't know that there is a prerequisite. So this establishes all of that. The AVCDL was created at Motional, and it has been graciously allowed to be made in a license of Creative Commons Share Alike version 4. The upshot of which is anyone who would like to can use, reference, and create derivative works of the AVCDL. Now, the location for this is up on GitHub, and it is maintained primarily, well, it is maintained by me, and it is updated on a fairly regular basis, as you can see here. Along with that, Motional has graciously allowed us to post PDF versions of a series of blog posts which I wrote to introduce and explain the AVCDL and various aspects of it. There is document tracking for the completion of the documents. As you can see here, we have a whole bunch of complete things, and there is one which is in draft state, which means that it's under review by a certification body, and that is the AVCDL phase requirement product UNECE WP.29 R155 work product fulfillment. there's a hint of what this is for. The location there at the bottom, just go to GitHub and look for AVCDL. The primary document is there. The working materials are there. The secondary documents are there. There is additionally material for the supplier interface, and that includes a autonomous vehicle centric manufacturer disclosure statement, so we can know what the practices are. There is a maturity self-certification or self-attestation, depending on how you would like to look at it, for how the company sees itself in terms of its maturity with respect to the processes that we laid out here. And a cybersecurity interface template and explanatory material for all of those are there. Finally, there's the set of blog posts which were mentioned. Now, a reason for all of this material being there goes into the category of none of us are secure unless all of us are secure. Also, it is the expectation of R155 that the manufacturer is responsible to make sure that stuff is being done appropriately throughout the supply chain. Additionally, at any point in the supply chain, you want to be able to attest that you're doing what you should be doing from a best practices standpoint. This material is difficult to wade through, the ISO standards, that is, and it can be difficult to know what all these practices are. And so over the course of the last 2 years, we have been working on getting these things to a point where they could be shared to make sure that not only our suppliers, but that all suppliers have the knowledge of, what are the best practices for the processes that you go through during a cybersecurity lifecycle. Now, as the Auto ISAC has attested to, security is not a competitive thing. Security is a collective responsibility. And so this works toward that end. Now, as you saw in a few slides ago, there are multiple documents that deal with satisfaction of various standards. 21434, 26262, and R155. The AVCDL documentation is being reviewed by a certification body so that we will be able to say that yes, we are checking all the boxes in all of those standards that we need to, and then people will be able to look at the AVCDL and say, yes, if I do this, then we're good. It's also out there to get feedback from the industry and to make it better. So with that, there are, of course, references that were included here. The AVCDL is full of reference material. Every one of the secondary documents and the primary document, all the best practices are all called out in each of the documents that they are applicable to, so that you can gain more depth on them. It's our belief that this material does not exist in a collected form anywhere else. And we hope that this contribution to the community will help advance cybersecurity. So with that, that ends this particular presentation.